Hello viewers, you welcome to the videos on chapter 11.1. The first thing we'll be discussing here is matrices. So what are matrices? Matrices, these are just a rectangular array. So we say that an n by n matrix is a rectangular array of numbers with m rows and n columns. So a matrix has n here, n means the number of rows, and n here means the number of what? Of columns. So you can see that here, this is what we call row 1. So this is row 1, this is row 2, and up to what? Row m. So you see you have m rows. And these are the column. This is column 1, column 2, column 3, and you can see we have dash dash up to this is column n. So we have m rows and n column. For example, if you have a matrix, this 2, 3, 1, 0, 1, 4. This now is called, it's a matrix because the numbers are arranged in a rectangular way. And the dimension of the matrix is given by m by n. So here, this means we have 2 rows. So this is 2 by 3 columns. And you can see the number aij, these are what we call the entries of the matrix. So the subscripts on the entry aij indicate that it is the ith row and the jth column. So for example, if I look at this number 2, this number 2 is representing what? A11. It means the element in the first row, first column. Now, if I go for element A23, it means the element in the second row and third column. So it's going to be 4. Now, if I say the element A32, A32 does not make sense because this matrix does not even have row 3. It stops at row 2. So you can see this one does not exist, right? Let me put DNE. So this is how we define a matrix. The important thing here is we call the dimension of the matrix, or another word for this dimension is the same thing. Anytime you hear dimension of a matrix, or you hear rank of a matrix, or you hear order of a matrix, it means the same thing. It's talking about the number of rows multiplied by the number of columns. So it means not multiply. When we say times here, does not mean you say 2 times 3. This does not mean 6. No. We are just saying that we have 2 rows and 3 columns. And if you have more than one matrix, the plural of matrix is called matrices. So take note of that. All right, so you can see that here are some examples of matrices. Now, and another thing we will discuss here is what we call the augmented matrix. It's called the augmented matrix. So what is an augmented matrix? An augmented matrix is a matrix we get from linear system. We just get it from where? From linear system of equation. Now, what does that mean? If you have a linear system of equation, look at this one. This is a linear system of equation. So from this system, we can get 2 matrices. We can get what is the coefficient matrix. So look at here. This, you can see this is 3. These are the coefficient of the variables. So this is the coefficient of x. So the coefficient of x will form the first column. So these are the coefficient of x. These are the coefficient of y. And these are the coefficient of z. So this matrix is what we call coefficient matrix. Right? And now the right-hand side here, this is what we call the the constant matrix. So an augmented matrix is simply a combination of two things. It's a combination of the coefficient matrix and the constant matrix. So this is just a simple example of it. So this one, what do I do? Because this one actually, if you look at this here, how do we form the coefficient matrix? The coefficient matrix is just the coefficient here. For example, this is the coefficient of x is 6. The coefficient of x in equation 2 is 1. But the coefficient of x in equation 3 is 0, because this you can write as 0x. So that is why you see here you have 0. Now, the coefficient, these are the coefficient of x. Now, this one, you see here, for the coefficient of y, here is 0, but you can write this as 0y. So it means the coefficient of y in the second equation is 0. That is why you have it here. And in the third equation, the coefficient of y is what? Is 7. Then you go to z. The coefficient of z or z here is -1. So you have minus. The coefficient of z in equation 2 is 3. So we have 3. And the coefficient of z in equation 3 is 1. Then this side, the right-hand side is simply 4, 1, 5. Now, sometimes we can put just a demarcated line like this. So this is what we call the augmented matrix. So if you have a linear system, you can easily form the augmented matrix by putting two matrices together. So let me highlight it again. This one here is called the coefficient matrix. So you can see the coefficient matrix in this case is 3 by 3. Why this one is called the constant matrix. And what is the size of this matrix? You can see this one is what? Is 3 row, 1 column. So this is 3 by 1. But the coefficient matrix, as you can see, is 3 by what? 3 by 3. All right. Okay, so this is just a simple definition of an augmented matrix and what matrix is. So the next thing is we were going to see how we can solve how to solve this linear system of equation. Now, if you have a linear system of equation, we can solve it. Already we know in chapter 10, we can solve it using substitution or elimination. But here we'll be talking about two different methods. These methods are what we call the Gauss-Jordan and the Gaussian elimination. But firstly, we will be talking about Gaussian elimination. But before we talk about Gaussian elimination, there is something very important which we need to talk about. Is simply, let's talk about this one, what we call the row echelon form and the reduced row echelon form. So I think I will just leave this one for the next video. Short, but let's talk about it there.